We're having a little bit of a flashback of a moment today and going back to Algebra 1 to do some radical review. Now, in this next unit, which is all about area, radicals come up a lot, where you have to do factor trees, you have to multiply radicals, so a lot of the rules that you learned in Algebra 1 are going to come back to haunt us this chapter. So for that reason alone, we're going to take a day and just kind of review some of this stuff. Now, notice that the directions for all of this say simplify each radical. There should be no decimals. So you're not going to plug the square root of 20 into your calculator and tell me what the decimal is. Instead, you're going to tell me oh, it's 3 radical 7, or whatever the simplified radical would be. Okay, so here's what we're going to do. I'm going to go through and do just a few examples with you on this paper, and then tomorrow your assignment will be to finish the rest of the examples. Okay, so one piece of paper for all this stuff, which is kind of nice. And let's just start off with number 1. So this says the square root of 49. Now, square root means what can you multiply by itself to get 49? You guys know the answer 7, so you don't really need a whole lot of help with this one, but realize that to help you with more complicated radical problems, you use factor trees. So if I were to do a factor tree on number 1, even though I don't need to, I would think what multiplies to be 49? Well, 7 and 7 does. Now, this shows me exactly what I'm looking for. These two, 7 times itself equals 49. Remember when you use factor trees, for every pair, one of those comes to the outside. So there's a pair of 7s, so 1 7 comes out, and just 7 is my answer. Okay, so let's jump to one like number 3 that's not as simple. Square root of 60, if I put that into my calculator, it's a crazy long decimal, which is not what they want. Okay, so I have to factor this down so I can simplify the radical. So I'm just going to think what multiplies to be 60. Okay, I could do 6 and 10. 6 multiplied, let's see, 3 times 2 would be 6. And then 10 would be 5 times 2. Every number that's prime, or places that can't break down any further, you circle those. So here's how I'm going to write my final answer. I'm going to get a radical going. For every pair of circled numbers, so here's a pair of 2's. There's one pair of 2's. For every pair, you bring one of those 2's out front. There aren't any other pairs. There's just a 3 and a 5 left. So those guys have to stay under together. And if they stay under or come out together, you multiply them. Okay, so this final answer would be 2 radical 15. Maybe we'll square our answers here for you. Let's look down at number 7. So it's the same kind of idea. 75 is not a perfect square. So to simplify it, I'm going to do factor trees. Let's see, I could do 25 times 3. 3 is prime, but 25 would break down into 5 and 5. All right, so I broke it down all the way. Get your radical going. I see a pair of 5's, so 1 5 comes out front. The 3 is very lonely and sad. He has no partner. Stays underneath. Okay, so 5 radical 3 is my answer. Now, let's go back and look at one like number 6, which this is where radicals got a little crazy. I feel like just simple factor trees isn't that bad for you guys, but ones like 6, those are weird. Okay, now here's what you want to do. You can't simplify 1 over 2 underneath. It's 1/2. It doesn't go anywhere. So what you could do is give each part of your fraction its own radical. That's the same thing as a giant radical over the whole fraction. Now, we know that, well, the square root of 1 is just 1. Square root of 2 would be a crazy decimal, and factor trees wouldn't take that anywhere anyway. So technically, I'm thinking this is my answer, 1 over square root 2. But I don't know if you guys remember this from Algebra 1. You cannot leave a radical in the denominator. It's just like one of those rules of math. Don't know who made it up, but you can't do it. So you have to do what's called rationalizing the denominator, which means you need to get rid of the square root on bottom. To do that, you multiply the top and the bottom by the denominator. So you would multiply by square root 2 over square root 2. Okay, I'm squeezing it in here. On top, 1 times the square root of 2 is just the square root of 2. On the bottom, the square root of 2 times the square root of 2. You can multiply the numbers underneath, and that would be the square root of 4, which that's a perfect square. The square root of 4 is just 2. And if you remember the little trick from last year, if you multiply something by itself and both of those are underneath the radical really just cancels out and you're just left with 2. So this would be an acceptable answer, square root 2 over 2. Kind of weird. Let's jump down and look at number 12, which kind of looks like number 6. It's another fraction. So here's what I'm going to do. I'm going to give each number its own radical again. If I thought about factor trees, 5 wouldn't go anywhere because 5 is prime. But you guys, I could simplify using factor trees, 24. So let's see, I could do 6 and 4, and then 2 and 2. And I could do 3 and 2 for 6. And I could rewrite this. Running out of space, hopefully you don't write as big as me. I see a pair of 2's, so 1 would come out. And 2 and 3, so 2 times 3, 6, would stay underneath. Okay, so I'm going to rewrite this as 2 radical 6 over radical 5. So it's pretty simplified, but here goes that rule again where you can't leave a radical on bottom. So you have to rationalize the denominator again, which means just multiply on top and bottom by the denominator, square root 5. Okay, on the bottom, the radicals just cancel because it's square root 25, which should go back to 5. So don't even overthink it. The square roots just cancel and you're left with 5. On the top, you have to do 2 radical 6 times radical 5. To do that, you multiply the numbers out front. So in front of radical 5 is just a 1. So I would do 1 times 2 and give me 2. And then you would multiply the numbers underneath the radical. 6 times 5 is 30. So the final answer would be 2 radical 30 over 5. Kind of gross answers here. Let's jump down and look at number 19. This one's a little crazy. For 19, notice there's an addition problem and a multiplication problem. Order of operations, you would multiply first. Okay, so kind of like we just saw in the last example, to multiply 2 radical little expressions here, you multiply the numbers out front. So 4 times 2 is 8. And you multiply the numbers underneath. So 10 times 5 would make this 8 radical 50 plus 10 radical 18. Now realize that unless these two things are called like radicals, you cannot add them together. Meaning like the number underneath the radical needs to be the same for me to put these together. I can multiply anything, but adding, they have to be like terms. So I need to break down both of these here. Maybe should have written a little smaller, but that's okay. So 18 would break down into 9 and 2, and then 3 and 3. Okay, so when I go to simplify this, the 10 is still out there, you guys. I would pull out a 3, because there's a pair, and I would leave that 2 underneath. Okay, for the 50, so that would actually become 30 radical 2, which I'm kind of running out of space here. I'm going to write it up here. So sorry. Hopefully you didn't write as big as me, and you could write 30 radical 2 underneath that. I have to do the same thing and break down 50. So let's see, I could do 5 and 10, 5 and 2, and I could rewrite this. The 8 is still out there, so I'm going to carry that down. I see a pair of 5s, so I'd bring that out. and the 2 would stay under. 8 times 5, I would have 40 radical 2. Okay, so here's what I'm actually adding together. I'm adding 30 radical 2 plus 40 radical 2. Those are now like radicals. They both have a 2 underneath, so I can add these together, and I'm just counting how many radical 2's there are. There's 30 of them here, there's 40 of them here, so there's 70 radical 2's. All right, let's go to the back, and I'm going to show you one of each on the back here, and then the rest of it you'll be responsible for tomorrow. For number 22, you want to solve it, and again, write your answers in simplest radical form. That means factor trees, not decimals. If I see a proportion, I'm going to cross multiply. So x times x is x squared, 6 times 8 is 48. Okay, I'm going to square root both sides to simplify and solve for x. Now, square root 48 is what I want to do. I know that I need to do factor trees, though, to kind of make this the best answer possible. So let's see, I could do 6 and 8, 3 and 2, 4 and 2, and then 2 and 2. All right, so let's figure out what this is going to look like. X would equal, I got a pair of 2's, actually I have 2 pairs of 2's. So 2 2's would come out together and get multiplied, giving me 4, and the 3 would stay underneath. So 4, radical 3 is my answer. For number 25, I see a right triangle. We're fresh off of doing a lot with these, and I've got 2 sides. To find the third, I can use Pythagorean theorem. So you guys should feel pretty comfortable from vectors doing that. Z would be alone, it's the hypotenuse. Okay, so let's see, 8 squared plus 14 squared is 260 equals z squared. And then I want to square root and do my factor trees. I know that this is divisible by 10 because it ends with a 0, so let's do 10 and 26, and then 5 and 2. And then 26, if you're stuck, just do divided by 2, which is the only thing. 2 and 13. All right, final answer, z would equal, let's see, you got a pair of 2's, so 1 2 comes out. 13 and 5 would stay underneath together and get multiplied. 2 radical 65 would be my answer. All right, last one, we're going to do number 27 together. Ooh, 27 says find the area. So that's what we're going to be doing this entire next unit, area of different figures. Hopefully you remember the area of a triangle is 1/2 base times height. Simplest radical form means no decimals again. Okay, so base and height, those are the 2 pieces that make the right angle. So I have the base as 12, but I don't have the height. So I need to do Pythagorean theorem to find that. So this time 18 is the hypotenuse. So I'm going to do height squared plus 12 squared equals 18 squared. Okay, so 12 squared is 144. 18 squared is going to give me 324. Then I would subtract 144. And I get 180. And then I would square root both sides. And here's where I'm going to do factor trees, because I don't want decimals, and I know 180 is not a perfect square. So again, it's divisible by 10, 10 times 18. And I could do 5 and 2, 9 and 2, 3 and 3. A lot of work on simple problems here. Okay, so the square root of 180, I could rewrite, I could pull a 2 and a 3 out and say 6, and the 5 would stay under. Okay, so the height is 6 radical 5 of this triangle. Now I can find the area. Woo! So So the area, I would do 1/2 times the base, which they gave me was 12, times the height, which I got was 6, radical 5. When you multiply these things together, you multiply everything except for the radical 5. So I would do 0.5 times 12 times 6. And then I would just stick a radical 5 on my answer, and I would say feet squared.